So we have seen what does running time of algorithm mean? What is order of growth? What does analysis of algorithm mean? If we, in order to solve a problem, if we have multiple algorithms, which algorithm is better? All those things. Okay. Now, so for example, in order to solve a problem, we have two algorithms, algorithm A and algorithm B, with running times shown here: 7n square, 8n plus 9, 4 into 2 power n plus 5n plus 6. Which algorithm is efficient to solve the problem? Which algorithm is efficient?
Algorithm A.
Algorithm B is not efficient. Why? Because here, what is order of growth? We drop lower order terms. Highest order term is 7n square. In this, only constants we need to eliminate. 7 we remove. So finally, we get n square. Otherwise, if you remove in 7n square, after removing 7, n square, this can be written as n into n. If we remove this, again in n into 1, we remove this, everything will boil down to 1. Everything will boil down to 1. We should not remove parameter n, input size parameter n. Only if there are any constants, that constants we need to remove. In the highest order term, only constant we need to remove. That we call it as order of growth or rate of growth. Here, order of growth is n square. Here, order of growth is 2 power n. Okay. So now from this, it is clear that algorithm A is more efficient to solve given problem. Hello. Now this is some more examples. What is order of growth in case of second example?
Sir.
Please tell me.
Sir, I have one doubt.
Please tell me, madam.
N square, sir. N square plus n by 2. Whole by 2. It is n square.
Yes, madam. So we have this now. 1 by 2 into n square plus 1 by 2 into n. That is our T of n. Here, which is lower order term?
Coefficient remove and
1 by 2
remove the lower order terms also.
This is lower order term. So we simply remove this now.
Then remove the coefficient also.
Next, 1 by 2 into n square. What is coefficient here? Constant coefficient. Constant
1 by
coefficient is 1 by 2. So finally, we will get only n square. Is that clear? So any doubt at this point? Okay. So what of first one? Which among these four, which is highest order term? These three are lowest order terms, no?
N log n.
We know that log n is smaller than n.
Yes.
So from that it is clear, no? That is n log n is smaller than n cube. Hence highest order term is 7n cube.
N cube.
7n cube. Again, 7 is constant here. We remove this 7 also. So finally n cube we get. Now if T of n is 20, what is order of growth? Order of growth is always in terms of input size only. 20. 20 means 20 can be written as 20 into 1. Is that okay? 20 into 1. And we know that input size is n. So 1 can be written as n power 0. T of n is 20 into n power 0.
That is 20.
Again 20, because there is only one term. That is only highest order term. So now what is that we cancel here? Only 20 we remove.
N naught means that is 1.
So now order of growth is n power 0. N power 0 means it is 1. Whether we write n power 0 or n 1, both are same. For example, T of n is similar to this. T of n is given as 30. What is its order of growth?
1.
What is its order of growth?
1.
order of growth is 1. 1 means it is actually n power 0. Okay. If T of n is given as 1, what is its order of growth?
N power 0. 1.
N power 0. If T of n is 1 crore,
Yeah,
Same.
same.
still that means
Any number.
if
Increasing.
T of n is independent of n, in all cases, no, T of n is 30, T of n is 20, T of n is 1, T of n is 1 crore. In all cases, T of n is independent of n, no? If T of n is independent of n, that means it is not depending on n of n. That means what is its order of growth? What is its order of growth? What is its order of growth? It is T of n doesn't contain n at all. Nothing in terms of n. Then what is its order of growth?
N, 1.
1 means it is n power 0. That's why it is 1. Is that okay?
Yes, sir.
Okay. Now fourth example. What is its order of growth?
3 power n.
We know that all these terms are smaller, no, when compared with 3 power n.
Yes.
But 3 power n, what are the constants here? There is no constant. Okay, no, there is no constant. Only 3 power n is there. Okay,
Yes.
that means 1. When 1, whether it is removed or not removed, it is 3 power n only. So is the definition of order of growth, is it clear? Because everything, whatever we are going to discuss hereafter, it depends only on order of growth. It depends on order of growth. If it is clear to everyone, then I'll proceed. If there is any confusion or doubt, then I'll take some more examples and I'll explain.
No, sir. Clear.
Okay, thank you very much, madam.
Clear, sir.
Okay, thank you, madam. So now this 1 means what? This is
Constant.
n power 0.
0.
Always order of growth is in terms of n, no? In terms of n. In terms
Hello, sir.
madam, please tell me, madam.
If the algorithm is like, for example, whether the number is prime or not.
Madam, that you know that
That kind of problems, how can we decide the order of growth based on the input size?
for that, if you want, I can explain, but it's better, I think, I'll explain after the class, madam, that I plan to explain after some classes. If you want, immediately after this class, I will explain it to you, madam.
Yeah,
Okay.
yeah. Okay, sir. Okay.
It takes minimum 10 to 15 minutes to explain that.
Okay, sir.
Okay. I'll come.
Thank you.
Definitely. That's why no, I said input size I am going to explain after some time. The reason is the same example I am going to explain. Whatever you ask, no, whether determining whether a given number is prime or not. The same example I will explain. Okay.
Okay, sir.
Okay, madam. Okay. So these are some basic orders of growth. 1, this is log n log n square, like this. Out of this, which one is lowest? Which one is lowest?
N not equal to 1.
This is lowest order of growth, no? Out of this, which is highest?
Factorial.
N factorial. So they are in this order, no? It is smaller, this is smaller. Is that okay? Is that okay? Okay. So let me ask you a simple one question. What can you say about order of growth of 2 power n plus 3 and 2 power n?
Same, sir.
Because 2 power n plus 3, we can write it as 2 power n into 2 cube. Is that correct?
Yes, sir.
So
Yes.
Same.
after removing 2 cube, can we say that it is equal to 2 power n?
Approximately equal.
That means that is order of growth point of view.
Huh.
Is that okay? Okay. Similarly, let me. So n plus 1 factorial and n factorial. So can we say that both have same order of growth?
n factorial. Suppose here let us assume 3 plus 1 factorial 4. No, sir.
That means it is impossible to write n plus 1 factorial as some constant
factor.
into n factorial for any constant, no? If at all we are able to write like this, then this constant we eliminate, then what happens? Then what happens?
N factorial.
N factorial we get, n factorial we get, is that clear? So that means what f of n and some constant into f of n. Is there any difference between order of growth of these two things?
No.
No.
In multiplication, no, sir. No difference.
Why? Because this constant anyhow we are going to eliminate. No, all constants.
Yes.
It is a
Both
constant.
are equal.
Both are equal.
Hmm.
Both are equal.
Sir, I think we can write it as n into n plus 1 factorial, but constant we cannot get in the
That's why, madam. This we can write it as n plus 1 into n factorial. This is fine.
Yes.
But this is not constant. No, we cannot
It
eliminate,
is not
remove this.
constant.
No? We cannot remove
Yes.
this. Is that okay?
Yes, sir.
It's not possible. This is not possible. Okay. Okay. Now, okay, we'll see some more examples. N power n and n factorial. N power n and n factorial, which has lower order of growth.
N power n.
Out of these two, which is more, which is less?
N
N to the power n must be greater than n factorial.
Madam?
2 power 4, it is 60. 4 factorial is 12.
N factorial is no.
N power n.
N to the power n must be greater than
Okay.
n factorial.
Okay. Let us simply, we know that n power n is n into n times.
N power n is greater than n factorial.
Correct, no, madam? Okay. Thank you, madam. This is n power n can be written as n into n times. Is that correct? N factorial, we know that it is 1 into 2 into and so on into n. Is that okay? Okay. Now, this we are order of growth is for large values only. Okay, for large values. This entire thing we can say that it is less than n. I will replace with 1. First n I will replace with 1. Second n I will replace with 2. Third n I will replace with 3. And this one last n as it is I will put. If there is some n here that I understand, if there is some n here that I will replace with n minus 1 and so on n like this. Is that correct? Is that correct? Is that correct? No, it's not correct. No, it's
But
not correct.
In bigger numbers, it is not equal.
We are order of growth means we need to always look for large numbers only. No, as n tends to infinite only. Now, is this correct? N into n is greater than 1 into 2 into 3 and so on up to n.
Yes, sir. Greater than 1 into, okay.
As per the given order here, we need to add one more super exponential. N to the power n. At
Yes.
the end, the highest one is n to the power n.
This we are comparing simply based on the definitions of n factorial and n power n. So now is this correct? Because I replaced n with 1, another n with n, 2, another n with 3, and so on. If I take any value, large value for n, is it more or less? Is this correct or not? True or not? Is this true or not?
Yeah, it is true.
It is true. It is true. Okay, any doubt at this point? Any doubt?
Okay, bigger. Okay, sir.
Small values we need not, for example, n equal to 1, if we take 1 power n, 1 factorial, both may be same. N equal to 2, 2 square and 2 factorial.
Hmm.
N
4
equal to 3 cube and 3 factorial.
27 is greater than 6.
That is correct. Okay. Instead of this, directly based on this, can we say? See, n power n is n into n times. N factorial is 1 into 2 into n. This is the, okay. Now all n's I have taken this side. The other side I have taken first to n I replace it with 1. Second n I replace it with 2. Third n I replace it with 3. And so on. Last n I'll keep it as n. Now from this it is very much clear that this product is going to be very much high when compared with the right
Left
side
hand
product,
side.
no?
Right hand side. Oh, yes, sir.
So this is nothing but n power n. This is nothing but n factorial, no? So which has higher order of growth? This has very much high.
N power
Order
n
of
is
growth
greater
of
than
n power n. If you want, we can add n power n also here. N power n here. So then it becomes highest. Is that okay? Okay.
Just as a part of curiosity, I'm asking, is there any algorithm which has complexity n to the power n?
That we can write, no, sir. N for loops we write. For example, for I equal to 1 to n, for I equal to 1 to n, for I equal to n to n, and print.
So how n times you can write loop for 1 to n? How many times?
Okay, sorry. Okay, for loop n power n you are asking, no?
Yeah. So is there any algorithm which has complexity n to the power n?
Is there any algorithm which has complexity n power n? For example, n is नाम क्या was the algorithm? If you want, I can give you.
Yeah, mathematically, I understood it is a largest term, largest method, but this as a part of curiosity, I'm asking.
That I haven't come across any algorithm, or I haven't seen such algorithm, sir. But if you want to simply know, I can give some array. I can take an array with n elements. I will run a for loop for I equal to 1 to n power n. Then I will do some array operation here. Array has size n. I can run a loop for I equal to 1 to n power n.
Sir, actually, until now, here no algorithm, I think.
Because standard algorithm, any algorithm that I haven't seen.
Yes.
But if we want, we can do something like this. One array we can take, madam, which contains n elements, and you can add a first element with last element like this, or do some calculations here, or print something here. Because this is naam ke vaste. Okay, no, only to say that
no.
That running time this much is possible. But actually to do some task, whether it is there or not, I don't know. I haven't seen.
Actually, no one can found, I think.
Because that algorithms, no, those are practically n factorial itself. We say that these are very difficult algorithms. Not only that, exponential itself, we say that they are very much difficult. Okay.
Yes.
Because in many of the books like Corman and all, they have given the order from 1 to n factorial. I've never seen n to the power n in any of the book. So as a part of curiosity,
okay, I have explained this to make the student to understand that how to compare orders of growth of two different functions. And this, I just want to say that n power n is more than n factorial. That is my intention here.
That is your conclusion.
My intention behind explaining.
mathematically it's perfect. Yeah.
Yes, sir. I haven't seen any.
Even in some competitive exam, they ask for the comparison between n factorial and n to the power n.
Like this only they ask, because our main intention behind this workshop also this is to so that we teach them so that they will be able to solve the questions which they encounter in competitive exams, mainly related to GATE. Okay. That is our intention behind this. That's why I am planning to teach accordingly. Okay. So similarly, if we consider 2 power n and n factorial, why it is smaller? Why 2 power n is smaller? Here I have written, okay, 2 power n is smaller than n factorial. Similar to this, can you give some justification? N factorial means 1 into 2 into 3 and so on n. 2 power n means now this 1 I'll replace with 2. This 2 also I'll replace with 2. This 3 also I'll replace with 2. This n also I replace with 2. Then what is that we get? Now I'll take product here. We'll take product here. Is that okay? This value is going to be 2 power n. This is n factorial. This is n factorial. Why? Because here every time I am replacing with a number which is smaller, except to first case. If n is more, except to first case, in all cases I am replacing number with a smaller number. This product will be definitely smaller than this product. Is that correct?
Yes.
Yes, sir.
Simply based on definition of what is n factorial and what is 2 power n. No?
N power n.
Okay. Okay. We'll see more examples. And we have already seen what does asymptotic analysis of algorithm mean. What does asymptotic analysis of algorithm mean? What does analysis? This I have already explained. No? Analysis of algorithm means what? Predicting the resources.
Algorithms require how much time and
predicting the
space.
resources the algorithm requires. Resources the algorithm requires. Predicting the resources the algorithm requires. That is analysis of algorithm. Mainly we talk about time. What does asymptotic analysis of algorithm mean? When n is input size, if we are interested in predicting estimating what is the amount of resources required, then this way of analyzing the algorithm is called asymptotic analysis of algorithm. So that if n equal to infinite, then what becomes more relevant? What becomes more relevant? As n tends to infinite, T of n is nothing but this gives us what? This gives us order of growth. That is order of growth. That means now finally we are concerned with only order of growth. We are concerned with only order of growth of running time of algorithm. Is that okay? Order of growth of running time of algorithm. How to get order of growth in running time? As n tends to infinite, large input sizes we take whatever we get in a function which is exclusively in terms of n, no other constant, nothing. Okay, no other constant, and which contains only one term. That is called order of growth. And this way of analyzing, this is called asymptotic analysis of algorithms. Asymptotic analysis of algorithms. Now, say one algorithm T of n is 23 into n square plus 4n plus 5. Another algorithm T of n is, this is A, this is B. 2n square minus 5n plus 20. What can I, whether asymptotically both are same? Asymptotically both algorithms are same or not?
Yes.
Yes, same. Order of n
growth
square.
Is n square. Order of growth is n square. B also order of growth is
N square.
n square. B also order of growth is n square. Okay, asymptotically both algorithms are same. Of equivalent. Are equivalent or not? Asymptotically. Running time, order of growth point of view, both are equivalent. Then does it mean that can we write something like this? 20 plus 4n plus 5 is same as 2n square minus 5n plus 20?
No, sir.
No.
You can
Because
write
here
only
we
in
are
the
algebraic
order of
numerical value we are comparing here. This notation we use for numerical value comparison. Okay, now whatever value, final value we get here, whatever value we get here, where n is input size, whether both are equal or not, that's what it denotes. It is like A equal to B checking. Okay, but here our intention is different. That is, after removing highest lower order terms as well as constant coefficients of highest order term, both are same. That means asymptotically both are same. So to do this, we have some difficulty. We need some different kind of notations with that meaning. Okay, now for that we have different notations where n denotes input size. Input size cannot, okay, no, it cannot be negative. So we take input size as 0, 1, 2, something like this. Okay, no? Input size as 0, 1, 2 like this. Now we are going to see five different notations. All of you should understand these notations. For this, what is required is only we need to understand what is order of growth. What is order of growth of n into n minus 1 by 2? What is order of growth in this case?
N square.
Here also
N
it is
square.
n square. Okay, if this much is enough for us. Okay, let us say f of n and g of n are two functions. F of n or g of n are two functions where n is input size. N is actually, this is defined over, it is not non-negative. And this we can even consider them as monotonically increasing functions. Monotonically increasing functions. What does it mean? If input size n1 is
There is no negative value.
n2, then f of n1 should be less than or equal to n2. So if you consider it as input instance, this is also some other instance, respective instance, then to solve small instance value, the amount of time our algorithm takes, it should be less. For a larger instance, it should take more time. With that understanding only, we are going to calculate what is running time and all. Special cases we handle separately. That means what? If distance is 100 kilometers, another distance is 1000 kilometers. It is expected that 1000 kilometer distance it should take more time or at least the same time as 100 kilometers, but not less than 100 kilometers distance time. With that understanding only. Okay. That is the meaning. Is that clear? What is monotonically increasing? Okay. Then what is big O? Okay. So simple. First, I will give you informal definitions of these asymptotic notations. So the first one, big O notation. So what does big? Say let us. What is big O of say G of n? Big O of G of n. It is a set. First of all, it is a set. Now, next question that comes to our mind is what are the elements of this set? It contains all functions in n. Any functions in n. But what is the guarantee we need to give? Order of growth of all functions in n. That I call it as say f of n. I call this as f of n. Order of growth of this function f of n should be less than or equal to order of growth of g of n. So that means it contains say all functions f of n such that O over G means order of growth. Order of growth of f of n is less than or equal to order of growth of G of n. We know what is order of growth. Okay, some example, simple example. Tell me what is big O of say n square. Big O of n square. What does it contain? Any function in n. But positive. Okay, no, it should be all should be positive. Okay, all should be positive. Any function in n, but what is the guarantee we need to give? Order of growth of whatever function we write here its order of growth is either equal to g of n or n
Or less
equal to
than.
g of n or smaller. Now big O of n square, you please tell me what is that I need to write here.
N cube.
N
N cube, is this correct?
N
Is
So we
cube
can
is
write
great.
n
is
square
it
also.
satisfied?
N
That
square, n cube.
Whatever
Any
we
number
write
that
here,
is not strictly.
it should be less than or equal to order of growth of n square. What is order of growth of n square? It is n square only. Order of growth of n square is n square only. Now whatever we write here, its
N,
order
n
of
naught.
growth should be less than or equal to n square. Less than or equal to n square. So what is that we can write here?
N,
N, is that correct? N's order of growth is less than n square. Is that correct? Is that correct or
N
not?
log n.
Yes, sir.
N power
N is-
0, is this correct?
n is less than n square, no, sir.
Correct, madam. That's why I have written no n. N is correct now.
Yeah, we can write n to the power 0 log n log n.
Log n.
Log n. Okay, n plus 3. Is that correct?
Yes.
Yes.
N into n plus 1 by 2. Is this correct?
Yes.
N square.
Yes.
Less
So
than or
yes.
less, yeah, you can add it.
Yeah, it's
2n
equal
square.
to, so we can consider.
2n square.
Yes, sir.
Yes, we can
3n
write.
square.
Yes, we can write.
4n square minus 8n minus plus 9 into log n plus 20.
Yes, we can write.
Only what is order of growth of this entire whatever I have written? It's order of growth is n square
N
only.
square, yeah.
Okay. Okay. Now anything else?
N log n.
Square root of n plus 4. Is that correct? Square root
Yes.
of n plus 4.
Yes, we can.
2 times square root of n plus 5 times log n plus
Yes.
n plus 3. Is that correct?
Yes.
Yes. So like this, is it possible to write infinite number of values here? Elements in this set?
Yes.
Whatever you put to n square,
less than or equal to
whatever
g
we
of-
get here, whatever we write here, if I write some constant, positive constant, is it going to be true?
Which
2n
constant?
square, 3n square, 4n square, 5n
Yes,
square,
yes,
6n
yes.
square, 1 by 2 into n square, 1
Yes,
by
yes,
2
we
into
can
n square,
write.
1 by 4 into n square, 1 by 4
Mm.
plus 1 by 2 into n minus log n plus 20. Is that correct?
Yes.
So like this, infinite number of values, elements, is it possible to write as part of this set?
Yes.
That means, is it finite set or infinite?
Infinite.
That means we can write infinite number of values, no? Okay, so that is fine. Okay, now our intention is here, whatever we write inside this set, its order of growth is either equal to n square or
Less than.
less than n square, Okay, now it is a set. Now what is big O of n square? Finally, we know that it is a set. For example, A is a set which contains some elements 2, 3, 4, 5. 1, 2, 3, 4, 5. If an element belongs to set, we write 1 belongs to A, no? Is that correct?
Yes.
Is it true or not?
Yes.
8 belongs to A. Is that true?
No.
No. Similarly, here, okay, here, can we write something like this? N into n plus 1 by 2 belongs to big O of n square. N
Yes.
into n plus
Yes.
1 by 2 belongs to big O of n square. Is that true?
Yes.
Yes.
Yes. N into n minus 1 by 2 belongs to big O of n square. Is that true?
Yes.
Is that
Yes,
true?
sir.
Yes.
Yes.
Similarly, 7n square plus 8n plus 9 belongs to big O of n square. Is that true?
Yes.
2n
Order
plus
of n
three-
square.
it's a big O of n square. Is that true?
Yes.
10 belongs to big O of n square. Is that true?
Yes.
Yes. No? So now is one notation, if you understand, all other notations easily we can understand. Okay. For that, to understand these notations, what is that we need to know is what is order of growth. What is order of growth of a function? Once we know what is order of a growth of a function, then what is big O of g of n? Big O of g of n is a function, a set which contains all elements, say f of n, whose order of growth is less than or equal to g of n. Order of growth of g of n. Is that okay?
Okay, sir.
Okay, let me ask you some. Sometimes here we use equals to belongs to symbol. Sometimes we use equals to symbol. Both meaning is belongs to only. Belongs to means it is member of that set. Okay. We use either this notation or this notation. Okay. Let me ask you some questions based on this. 2 power n plus 5 is, okay, hereafter I use this big O of 2 power n. Is this true or false? 2 power n plus 5 is big O of 2 power n.
It's true.
True, sir. 2 power n, 2 power 5.
2 power 5.
2 power n
That
plus
is
5 can be written as 2
2 power n, 2
n
power
into
5.
2 power 5.
Okay, thank you. 2 power 5. 2 power 5, anyhow it goes. So it is true. It is true. 2 power 2n, it is big O of 2 power n. Is that true or not? That means what is that we need to
Yes.
check? What is
2
that
power
we
2
need to
into
check?
2 power
Is
n.
it possible to write 2 power 2n as some constant into
2 power n.
2 power n? If we are able to write like this, then what does it mean? Both have
Same growth.
same growth. Otherwise,
Order of growth.
otherwise clearly we know that it can be more, no?
Yes.
Only
It's 4 to the power n, no?
whether both are equal or not, that is the confusion. Otherwise, clearly it is visible that 2 power n is smaller than 2 power 2n, no? Is that okay? Only equality is confusion for us. Now, is it possible to write?
How 2 to the power 2n is lesser than 2 to the power n? Because it is 2 to the power 2n.
That's what I am saying, sir.
4 to the power n. Yeah.
That's what I am saying. So this is definitely not smaller than 2 power n.
Yes.
It is very much clear that it is more than, okay, 2 power 2n less than 2 power n is false.
False, yeah, of course.
We know that order
Less than or equal to.
of growth of 2 power 2n is greater than or equal to order of growth of 2 power n. This is definitely true, but is it equal or not is the question now. Is it equal or not is the question. Okay, is it equal or not? When does it become equal? If at all it is possible to write 2 power n as shown there, some constant into 2 power n. Is it
Yes.
possible to write like this?
And that constant is 2 power n.
What
Growth
is a
is
power
same.
mn?
Fine, sir.
We know that a power mn is a power m.
Into a power n.
Okay,
A
a power
power
m plus
n
n
into
is
a
a
power
power
n.
m into a power n. No? A power m plus n is a power m into a power n. So this 2 power
Yes.
2n we can write 2
2
power
power
n
n
into 2 power n.
into 2 power
This much we know.
into 2 power n.
Okay. Now question is
And
it
the 2
possible
power
to
n is
replace 2 power n with some constant? That is the question now. If at all it is possible to replace with some constant, then both will be same. Both will be same. Otherwise, both are not same. Is that okay? If at all we can replace 2 power n with some constant, okay, 2 power n with some constant, then both become same. Otherwise, they are not same. Is it possible to replace 2 power n with some constant?
Not
Yes.
possible.
It is
Not possible.
no, it is a function of n. How can we write it as some constant? Is there any doubt? Is it
No
clear
doubt,
to
sir.
everyone? Is it clear to everyone?
No, sir. Here a power mn, a power m plus n.
A power m plus n, madam.
Okay.
This is plus n.
Okay.
A power m plus n is same as a power m into a power n.
A power
We
n.
know
Right,
that.
right.
We know
Right,
that.
sir.
So now 2 power 2n can be written as 2 power n into 2 power n. That's why
Yes.
it becomes 2 power n plus n, which is same as 2 power 2n.
Yes, yes.
Power 2n. Now the question is whether 2 power 2n and 2 power n have same order of growth or not. When do we say that both have same order of growth? If 2 power 2n can be written as some constant into 2 power n, then we say that both have same order of growth. Then we say that both have same order of growth. But is it possible to replace 2 power n with some constant so that both will have that value is same as 2 power 2n?
No, it's not possible to replace.
It is impossible, no?
Yes.
It is not possible.
It is not possible. That means what? Both have, they do not have same order of growth. Order of growth of 2 power n is not equal to order of growth of 2
2
power
power 2n.
2 power n. 2 power n. 2 power 2n is not equal to order of growth of 2 power n. Now clearly what is true? This equality condition is gone. Now which is more? Which is more? Which is
2
more?
power 2n.
2 power 2n
Sorry?
is more. So that means here it is higher order of growth. Here it is lower, no? Now according to big O notation, what should be true? Right?
G of n should be
Left
higher
hand side,
than.
low value should be there. Right hand side,
Higher
Yes.
order.
it should be like this, no?
Yes.
So now is it true or false?
This
Is
is
that
false.
true or false? It is false. All of you agree with this? Okay. Now let us take one example. Log n factorial is big O of n log n. Big O of n log n. Is this true or false? Log n factorial is big O of n log n.
It is true, I think. It is true, sir.
Oh, why, madam?
False, sir.
Sir,
False.
log n factorial will be lower than n log n.
Sir, actually it is false. Here n log n is a linear arithmetic. N log n is a linear arithmetic, sir.
Yes, madam.
And log n factorial is a higher.
But we should say, no, madam, order of growth, it is strictly how to compare that. For that, okay, let us take n factorial. N factorial. So this is same as 1 into 2 into 3 and swan n, no? Is that correct? Is that correct? We know that this value is lower than n into n into n. Is that correct? Okay.
N factorial.
What is right side? N into n into n? What is that?
This is n okay, n times okay, unswan. Okay, unswan is missing. Unswan n times, which is same as n power n.
Okay.
So from this we know that n factorial is less than n power n.
Yeah, I agree.
Oh, we have already discussed, in fact, this.
Yes, 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 I agree.
Now let us take log both sides. Log n factorial should be less than log n power n.
n log n.
So that means what is log n factorial as it is we write? It is same as n log n.
No, both are equal.
We know that log a power m base b is m log a base b, no? Okay. Based on this, we have written this. Log a power m base b is same as m log a base b.
Log a base b.
Now from
That's fine.
is it clear?
That's clear.
Yes, yes.
Okay. So from this, what is that we can conclude?
Both are equal.
It is true.
No. We are not concluding. We have not concluded here. Both are equal, no, madam.
No, it is-
Order of growth of
The
n
condition is
factorial,
true.
we have shown that it is smaller than order of growth of n log n.
Yeah.
Small,
We were able
less
to
than.
show this. It may be equal also, that we don't know. At least we were able to show that order of growth of log n factorial is strictly lower than order of growth of n log n. Is this correct? Is this
Yes.
correct or not?
Yes,
Because,
sir.
no, okay, simply based on that, we applied logarithm both sides. We have got this. Now you tell me. That means which side is it less or not? Is now you tell me whether third condition is true or not? Whatever
True.
you presented.
True.
True.
Now true.
It is true. Okay, madam.
Yes.
Okay. But there is a nice formula for finding factorial of a number. Okay, no? That is known as Stirling's approximation formula. So this is one way of finding n factorial. There is another formula, Stirling's approximation. It doesn't give exact result, almost close result. Okay, that's why it is Stirling's approximation formula for finding factorial of a number. It says that n factorial is approximately equivalent to root to 2 pi n times n by e whole power n. N by e whole power n. It says that n factorial value is approximately equivalent to root to 2 pi n times n by e whole power n. Is that okay? Is that okay? Because this is formula, we need to remember that. Okay, this is a formula. Now, okay, let us write some formulas which we are. What is log a by b? This can be written as log a minus
Log A minus log B.
Log a minus log b.
minus log b. Okay, thank you. What is log ab?
Log A plus log B.
Log b.
Log a plus log b. Okay. Now we apply logarithm. What is log n factorial? Is we also know that log a power
Log
m
n
is
plus log n
m
plus
log
log n minus 1.
okay. So this can be written as log of 2 pi n whole power 1 by 2 into n by e whole power n. Okay, let me take a new sheet. Okay,
N by
let us
e
complete
whole
here.
power
Again. Okay, now this entire thing we can write it as this is A, this is B form. So this simplification shall I write directly?
1 minute, sir. I
It is
will.
A, it is B, it is of the form log
N
2 pi
factorial.
n whole power 1 by 2 plus log n by e whole power n. Is that okay? First one I have taken it as A, second one as B. It is of the form log AB. We know that log AB is same as log A plus log B. Hence we have written that. Is that
Log 2 pi n whole power of.
It's fine. Yeah, it's fine.
okay? Now this first quantity, this one, green color, this one, it is of the form log A power m. It is of the form log A power m.
Yes.
So
Yes.
we can write it as 1 by 2 times log 2 pi n.
Yes.
Now second quantity, it is of the form log A power m as well as log A by b, no? Both we can apply, no?
So n log n.
First, let us apply this. N will go out. It will be log of n by e. Log of n by e.
N log. Oh, okay, sir.
Next, if we expand that,
Yeah, n
N
log
minus
n
log
e.
so what is that we get? Okay. So directly I write here. So log n factorial, we can get it as 1 by 2 into log 2 pi n plus n into log n minus log e. Is that okay?
Yeah, fine.
Now you tell me what is its order of growth? What
N
is
log
its
n.
order of growth?
N log n.
That is here. What are smaller terms? This is
1 by
smaller.
2 log 2 pi is
Log
smaller.
E is the smaller.
So what is highest term here?
N log n.
Log n. That means its order of growth is
N log n.
n log n. In fact, they have same order of growth here. In fact, they have same order of growth here. Is that correct? Is that correct? Is that correct?
Yes.
Yes.
Okay. So both have same order of growth. If same order of growth means automatically this condition is true. This condition is true.
Now log n factorial equal to order of n log n is true.
That means that we can change. If we can understand that order of growth of log n factorial is n log n, then notation is different. Instead of big O, we may use some other notation. That is different. No. Log, what is order of growth of log n factorial? Therefore, order of growth of log n factorial is n log n. If we know this, we can play with these notations later. Okay.
Nice.
So big O notation, is it clear to everyone?
Yes, I have one question here.
Please tell me, sir.
If I have a two algorithm, one has a complexity log n factorial and other has a n log n, can I say both are performing same with respect to order of growth?
Order of growth point of view same, but the actual number of operations performed, no, it may be different, no, sir.
Okay.
See, for example, 2n square. Okay, in one algorithm, number of comparisons performed is 2n square. In another algorithm, number of comparisons performed is 1 by 2 into n square. Order of growth point of view, both are same, no? Asymptotically, both are same.
Yeah. So I'm asking with respect to order of growth only. Both are same.
Order of growth, both are same, no, sir?
Yeah. Great.
So if big O notation, is it clear?
Yes.
Because if one notation is clear, all other notations, it is exactly same. Only that condition changes. Is that okay? Okay. Let us see this one more time. Okay. Please, those who have not understood, please read what is big O notation definition. These are informal definitions. Formal definitions are there that we will discuss later. First, we try to understand what is big O. Okay. Now, what is big omega mean? What does big omega mean? It is clear. So here also, big omega of g of n, it is a set. Then we need to say what are the elements of this set. It contains all functions, say f of n, such that what is order of growth of f of n? Order of growth of f of n is
higher than,
is greater than or equals to also there. Order of growth of g of n. Here it was less than or equal to. Here it is greater than or equal to. That's all. Okay, let us see what is big omega of n square. N square, is it member of that set? Is this correct? Is that
Sorry.
correct? Big omega of n square, is n square member of that set or not? That means
Yeah,
what is
correct.
that I'm asking is,
Correct,
is
correct.
n square belongs to big omega of n square or not?
Yes, correct.
Why? Because both have same order of growth. Same is also allowed, more is also allowed. N cubed, is it belongs to big omega of n square?
Yes, no.
What
Just a
it
minute.
should be more, no. Equal
Yes.
or more. N
Yes.
cubed is greater than or equal to n square. Is that correct or
Yeah,
not?
it is. Yeah, correct, correct.
Yes, correct.
N power 4n square minus 6n plus 4 into log n plus minus 20
Yes.
is big omega of n square. Is that true?
Yeah, correct, correct,
Yes,
correct.
correct.
N into n plus 1 by 2 is big omega of n square.
Yes,
Is that true?
correct. Yes.
That is correct. Okay, similar now you please, is this true? N power 2.5 is big omega of n square. What is that we need to check? Right hand side, whatever elements are given, their order of growth is more than n square or not, we need to check. Is whatever elements are given here, whether they have more order of growth or not, or equal, at least same. All have a higher order of growth or equal order of growth as n square, no? Is there any confusion? Is
No,
it,
sir.
No.
is it clear?
Sir, if one asks for complexity of any algorithm, and if other is replying, the complexity is big O of n factorial,
Yes, sir.
is it right or wrong? Complexity of any algorithm. If someone replies,
Because
big O of n factorial.
Okay, because of n factorial means, for example, same question you raised, no, sir, earlier in the previous lecture. If someone gives n power n time algorithm, then your thing goes wrong, no?
Yeah, but most of the cases, somebody asks, complexity of complexity of sorting algorithm, no complexity of bubble sort. If someone says big O,
yes.
Then why examiner says it is wrong?
So see, okay, I will explain those things also. For example, any function t of n is given, sir. It is positive. It is positive function, whatever values here. If I if I say that t of n is big omega of n power 0, is this correct or not?
Yeah, it's correct.
Because here order of growth will be n power 0 or more, no?
Yes.
Is that correct, no, sir? But what is the but naam ke vaste it is correct. For example, you just wanted to buy, say, Corman textbook. You know that it is very good book. Okay, no, Introduction to Algorithms by Thomas H. Corman.
Yes,
okay.
yes.
You asked one of your colleague, okay, no, what is the cost of the book? That person said, oh, it is very nice book here. I read that so many pages, something like that. And the cost is 1 rupee or more than 1 rupee, he said. Then you say, okay, no, you got what is this fellow is saying? Then you asked one more colleague. He said it is 100 rupees or more than 100 rupees. Next person you asked, he said it is 600 or more than 600. Next one more person you asked, he said it is 800 or more than 800. Another person you asked, he said it is 1500 or more. But no one is lying. No one is lying. Okay. Among these, which is your favorite answer, sir?
Very close to the.
You need to have minimum 1500 rupees with you, okay, to get that, to buy that textbook, no? Greater than or equal to 1, is it wrong? It is also correct answer, but you not that much useful answer, no, sir?
Yes.
Tight bound.
That means, okay, because that we'll discuss later. Okay, that means big O notation gives lower bound, okay, no? But big omega notation gives lower bound. Lower bound should be as high as possible. Okay, we'll come to this step by step later after some. Okay. Like that, what you are saying is the other direction. So you wanted to buy again Corman textbook, CLRS textbook, and you asked your friend, he said that cost of the book is 1 crore or not more than 1 crore. One more faculty is, your colleague said it is 1 lakh or more than 1 lakh. Another faculty said 10,000 or less than 10,000. Another faculty said 2,000 or less. Another faculty said it is 1,600 or less. No one is lying. Out of this, which is your favorite answer, sir?
1,600.
That means 1 crore means everybody knows, no, there will not any book, it doesn't cost more than 1 crore. It is correct answer, but it useless answer. It doesn't give any information about actual cost of the book, no? More
Meaningless.
because that is correct only, but it
Right,
doesn't give any additional information which we are looking for. Correct, no?
Yes, sir. You nicely explained this question.
Nice,
okay,
nice.
okay. Thank you, sir. Thank you. Okay.
Yes, sir.
So this is big omega. This is the definition of big omega. Okay, because I stop at 7:45 because we started 15 minutes late. Okay, today's class after that. This is big omega notation. Next, similarly, there is another notation. What is theta of g of n? It is set of all functions with the same order of growth as g of n. With the same order of growth as g of n. Is that clear? That means what is theta of g of n? It is set of all functions, say f of n, such that it is set of all functions, say f of n, such that order of
Less than.
growth of f of n is
Less than or
same
equal to.
as order of growth of g of n. Is that okay? We know what is order of growth. Once we know what is order of growth, then these notations are very simple. If we don't know what is order of growth, then this will be very much confusing. Okay. Now, what is simply they have given what is theta of n square. What is theta of n square? That means it is set of all functions. The same order of growth as that of n square. Is n square is having same order of growth as n square? Yes. What about n into n plus 1 by 2? Same.
N
What is 8n square plus 9n plus 20? That
N
is also
square.
same.
Same.
What about this?
Four.
Small simplification.
That is
N.
also same, yeah.
This is only n power. This is same as n power log a base b. No, we know this now.
Yes.
N power.
So from this,
Yes,
this
yes,
can be
yes.
written as n power log 4 base 2 plus 6. We know that log 4 base 2 is 2. It is n square plus 6. N square plus 6, what is order of growth?
N square.
Square.
N square, it is same only like over accented. Okay. So this is also n square. Order of growth is n square. Now you tell me, is this set finite or infinite? Unlike the other two sets, is it finite or infinite?
Infinite.
Finite.
Infinite. Because we can write 2n square, 3n square, 4n square, like this, whatever we want, we can write. No, 4n square plus 5n plus 6. Like this, so many things we can write. No.
Yes, sir.
Okay. It is also infinite, similar to other things. Okay, it is infinite. Now, what about what is little o? So we have discussed three things. One is less than or equal to 1. Next one greater than or equal to. Next one equal to. Next one is strictly less than. So one side f of n, other side g of n. This is with respect to order of growth. This first one is big O. Second one is big omega. Third one is theta. Fourth one is little o. Little o means what? It is also same as big O. Only difference is same order of growth is not permitted. It is strictly lower. What is little o of n square? Is the definition clear? Is the definition of little o clear?
Yes, sir. Yes.
What is little o of n square? Whether n square will be part of it or not.
N square is not a part of it.
N square is not part of it. Why? Because equal order of growth is not permitted. No, it is not part. It is not part. n power 1.5, okay, that is smaller. Root n, this is also smaller. N, it is n power 0, that is also smaller. All are small, no? Is that okay?
Okay, sir.
Yes.
Now, what is similarly, one more notation, it is strictly greater than, that is little omega. That is little omega. We have, what is the definition here? Once you know what is little o, it is at the other side. Which one should have more order of growth here? G of n or f of n?
F of n.
Little omega of G of n is
F of n should be higher.
F. It should contain
Yeah.
all functions
F of n
such
is
that
greater.
order of growth of f of n is strictly
Higher.
higher than order of growth of
G of
n. Is that okay?
Yeah, fine.
Okay. Now I think this is straightforward, no?
Yes.
Square, it is all or more, no? This is also infinite set. This is also infinite set. Okay, let me ask one simple question. One question. If f of n is big O of G of n, then f of n is little o of G of n. Is this true or not?
F of n is big O of G of
If f of n is big O of
Yes,
G of n, then f of n is little o of G of n. Is that true or not?
No, it's false.
No, false.
false.
Because it may or may
Equal
not be
to
true. It may or may not be true. Why? Because if something is false, if we can give one counter example, that is sufficient, no? One counter example, it is sufficient, no? For example, say f of n is n square, G of n is, okay, f of n is 6n square plus 5n plus 4, G of n is n square. G of n is n square. Whether first if condition is satisfied here,
Yes.
Yes.
whether this condition f of n is little o of G of n, is it satisfied?
No.
No. That means
Second
one
condition
this
not.
is a counter example, no? One counter example if we give, that is sufficient. That means this statement is not true. This is false. What about its converse? What about its converse? If f of n is little o of G of n,
True.
then f of n is big O of G of n.
True. True.
This is its converse. No, it is P implies Q means this is Q implies P, no? That is called, okay, Q is there. Okay, this is R implies S. This is S implies R. Is this true or not?
Yes. True.
This is true. Okay. Okay. One example which covers all cases we discussed now. We know that 8n cube plus 9n square plus 10n plus 20. Its order of growth is
N cube.
N cube.
n cube. All this 12, every one of you should understand. Even if you are not able to follow at least one among these 12, that means you have not understood asymptotic notations clearly. Okay, there is no half I understood, half I not understood. Only 100% understood or not understood. Only that much. Okay, all 12 you should understand. Okay, now, okay, again for your understanding, less than or equal to means this is analogous to our less than or equal to 8 less than or equal to 9. This is say f of n, this is G of n. We have big O. 20 greater than or equal to 10. Analogous to this, we have big omega. Next, 10 equals to 10. Order of growth point of view equal, it is theta. Next, 8 less than 9. Similar to this, we have little o. Next, 20 greater than 10. Similar to this, we have little omega. Is that okay?
Yes, sir.
Yes.
Okay, these are 5 notations, no, to compare real numbers we use, no. Similar to this, we have big O here, but f of n and g of n sides should be fixed. It is with respect to order of growth. This is numerical value comparison. Okay. Now, you please tell me. Please tell me. Okay, one more thing if you want. Big O notation, I'll write definition. Big O of G of n is f of n such that order of growth of f of n is strictly less than or equal to, order of growth of G of n. Correct, no? Order of growth of G of n. Once you know this, all other four things, remaining four, automatically, I think you will be able to get. Okay. Now you tell me, is this true or not? First one is true or not?
First is true.
It is true. Every one of you, if you have any doubt, you please ask me. You can interrupt me and you can get it clarified. Okay. What about second one?
It's true.
True.
Because if this itself is
Less
true,
than or equal to.
automatically this will be true or not? Because it is less than or equal to n cubed means automatically
False.
less than or
Order of
equal to
n, false.
True. Third one false.
Third one, this is false.
False.
Fourth one,
True.
True.
because this side it is n cubed. N cubed is
Greater than or equal to.
to n cubed.
Greater than or equal to.
Here it is n cubed is less than or equal to. N cubed is less than or equal to this one. Okay, that is the meaning here. Is that true? Or true?
No.
This is correct now? Fourth
Yes.
one is true.
Yes.
Fourth
Fourth
one
is
is
correct.
true, sir.
Fifth one?
True.
One
Fifth
also
one
true.
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 Fifth one is also true. Sixth one?
True.
True.
Yeah, true.
Sixth one is also true. What about seventh one?
False.
False.
But sir, fifth. Okay.
False.
Please tell me, madam.
Yes,
Seventh
yes,
one false,
correct,
sir.
correct.
Okay, okay.
Okay. What about eighth one?
True.
Eighth one, no.
True.
True.
Sir.
Okay. What about ninth one?
False.
Ninth
False.
False.
Tenth?
True.
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 Because strictly lower. That means n
Ah,
cubed is strictly
yes.
lower than n power 4. That is the meaning, no?
True.
It's true.
It is true. What about 11th one?
False.
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 This is false. 12th one?
True.
Eleventh one false.
Strictly greater.
Strictly greater.
Is that correct?
Yes.
Yes.
Okay. Now, same this 8 n cube. Okay. This let us call it a T of n so that I can easily write. So T of n is big O of n power 1 crore. T of n is big O of n power 1 lakh. T of n is big O of n power 1000. It is n power 100. It is n power 10. N power 5. N power 4. All among this, is there any wrong answer?
No, all are right.
1000.
So if T of n is this, if I represent like this, is it wrong?
All 10 multiples.
True.
All are true or not?
True.
Out of this, which is your favorite answer? If options are like this, among this, which is your favorite answer?
O of n power
Last one.
plus
Nearest
O of
one.
n
N power 4.
If O of n cubed is also there,
O of
Cube is
n
the
power
answer.
cube.
n cubed is our favorite answer. Similarly, T of n is big omega of 1, big omega of log n, big omega of n, big omega of n log n, big omega of n square, big omega of n square log n. Our option big omega of n power 2.9. Sorry, n power 2.9. Among these, are there any wrong answers?
No.
Big omega of n square. Big omega square log n.
All are right.
True.
All are true. Out of this, which is your favorite answer?
Omega of 1. Big omega of 1.
No. Big omega of n to the power
This
2
is
to
correct.
2.9.
But what is our favorite answer? Provided we know that T of n is this. That means
last one.
Omega of 1.
whichever is close to the actual order of growth, or whichever gives more information about the actual order of growth of T of n, that becomes our favorite, no?
N power 2.9.
N power 2.9. Is this our favorite? All are correct, but this is our best answer. If n cubed is there,
That is
it
the
becomes favorite
cube.
and best, no?
no
That is
equal
the
to will
best.
not come. The equal to will not come.
That becomes our favorite answer.
Mm.
Is that okay?
Mm.
Okay. Now, last example, let us say, to solve a problem, okay, one student has given log n whole power 4 algorithm, another student has given n time algorithm. Which is better, or out of this, which has lower order of growth?
Log n power 4.
4.
1.
Okay, instead of log n power 4, log n power 400.
Still.
Yes, log n power 400.
Is it which is small?
Log n power 400.
400. So in general, it is shown that log n power c, where c is a constant, is strictly lower than n power
Big O of n.
n power, say some d, where c and d are constants. So log n power c, okay, no?
Mm. Mm.
Log n power c, this is little o, this is not big O, little o of n power d. That means what?
Little o.
Be less than.
Order of growth. This is called polylogarithmic function. It is a polynomial in logarithm. Polylogarithmic function. Polynomial in logarithm. This is polynomial function, no?
Yes.
This is a polynomial function. So order of growth of polylogarithmic function is very much small when compared with order of growth of polynomial function. Order of growth of polynomial function. So that is, out of this, which has lower order of growth? This.
Log n power 400.
Okay, one algorithm, it is like this. Another one, n power 0.00001. Which is better algorithm out of these two? That is faster algorithm.
Log n power 999.
This is very much small when compared with this. That means this is faster. This is faster. Is that
Yes.
okay? Okay. Similarly, one student has given algorithm to solve a problem whose order of growth is this much. Another student has given algorithm whose order of growth is 2 power n. 2 power n. Which is better?
N power 9999.
This is very much
Left
better.
hand side.
This is polynomial. This is exponential.
Exponential.
Is exponential. Okay, that is in general similar to this. Here also it has been proved that n power c, okay, no, where c is a constant, is little o of a power n, where a is greater than 1. Why a is greater than 1? Please tell me.
0 power n means?
No, 1 to the power n will become constant.
No, if it is 0.5, so can we say that n square is little o of 0.5 whole power n?
.5.
Yes, we can write.
This is false. That's why I said a should be greater than 1. See, if a number is 0.5, if I increase the power, then it becomes 0.25. No, value gets reduced, no?
Reduced.
As n tends to infinite,
Yes,
this tends to 0.
Yes, sir.
To 0. As n tends to infinite, this becomes 0. Becomes converges to 0. But here, as n is infinite, it becomes infinite. No, it close to infinite. Is that okay? That's why a is greater than 1 is important here.
Condition is important.
A is greater than 1. That means what? N square is little o of strictly lower than 1.2 whole power n. Is this true?
Yes.
Yes.
Yes. Okay.
Yes.
Okay. Now, whatever I think we have discussed so far, if there is any doubt, you please tell me. These are like alphabets of this course. Okay. You
learned today so much, sir.
Why?
Can
Why
you
so
please
many?
send the video recording of this, sir, so that we can once again